Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial, we're going to be looking at this summary activity where we are going to be working with a bar scale, a ratio scale, and a line scale, to help us answer questions that are given to us, right? So please take note, in this question, we're going to be working with a bar scale. I'm going to be showing you how you work with a ratio scale, how you convert a bar scale into a ratio scale, right? So just take a screenshot of all these questions that we will be going through together. So just make sure that you're taking a screenshot of all these pages that I'm showing on the screen right now, because we are going to be answering them together. So please make sure that you do them on your own, and then we get started. Okay. So it says a map has been given with the following bar scale. So we're given a map, okay? And this map, right, has this bar scale, okay? First question is asking us, what does 1 centimeter on this map equal? So remember, I did mention that when you're working with a bar scale, ladies and gentlemen, the first thing that you need to do is that you need to measure that bar scale, okay? You need to measure that bar scale, okay? So let's say we measure, our bar scale. Let's say we measure from this point, length of this first bar is equal to 3 centimeters. Okay, what does this mean? Remember, I spoke about this, that even if you decide to measure the whole bar from there to there, okay, that is also fine. It just means that if you measure the whole bar, right, then that would mean that in this case, let's say if I would measure with my ruler, it would be 6 centimeters, okay? But then I just chose to just measure that first bar only, okay? So let's say I measure that first bar with my ruler, and I measured that first bar to be 3 centimeters. So what does that mean? It basically means that, okay, 3 centimeters on the map is equal to 15 kilometers in real life. 3 centimeters on the map is equal to 15 centimeters in real life. So now we've translated our bar scale into an equation that we can use. Okay, so now life becomes very easy for us. Okay,
you get my point.
So now this question is asking us, what does 1 centimeter on this map equal, right? So that basically means that now, using that answer or that ratio that we've now determined from measuring our bar scale, simplify that further to determine what is 1 centimeter on the map equal to. Okay, so that's basically what the question is asking us. Okay, so we're going to take that 3 centimeters is equal. Okay, I think maybe some people might not see this blue. So it just means that 3 centimeters is equal to 15 kilometers, but the question is asking us, what is 1 centimeters on this map? So it just means that you just want to simplify this ratio or this equation to be in the form of 1 centimeter is equal to what? That's basically what we want to do. So for us to simplify that, we are just going to divide both sides by 3, not 3 centimeters, but by 3. If you divide that side by 3, you divide that side by 3, what do you get? You'll get that then 3 divided by 3 is 1 centimeter is equal to 15 divided by 3 is 5 kilometers. Okay, so we've basically, this part here, question A, is just asking us to simplify this equation of our bar scale, right, to be in the form of 1 centimeter is equal to how many kilometers. But even if you decided that you wanted to work with, I'm just saying, if you're given a map and you just wanted to work with this equation the way that it is, as 3 centimeter is equal to 15, it will still give you the exact same answer. Okay, but in this question, they're just asking us, right, to simplify it further so that it's in the form of 1 centimeter is equal to how many, units, kilometers in real life. So that's that. Okay, so we've answered that question, that 1 centimeter on the map equals 5 kilometers in real life. Okay, now let's look at this one. It says Anya has written on her map a ratio scale of 1 is to 150,000. Check if she converted the bar scale to a ratio scale correctly. Okay, so now I'm just going to use this main equation, right? This main equation of 3 centimeters is equal to 15 kilometers. I'm just going to use this main equation, right? So now we want to convert this bar scale, because it's a bar scale. Remember, we got that equation from the bar scale. So I want to convert this bar scale into a ratio scale. What do we do? Because now Anya has converted this bar scale into a ratio scale. And after she basically converted it, she got the answer of 1 is to 150,000. So we want to check to see if she's converted the bar scale correct. So what is it that we need to do? First thing we do, we're going to just take 3 centimeters. I'm going to do this in 2 ways, actually. Let's do it in 2 ways, because there's 2 ways in which we can do this. So the first way, we can just use this original equation, okay? And we want to convert that into a ratio scale. What do we need to do? It's going to be 3 centimeters is to 15 kilometers. So now remember, if we want to convert, or if you want our scale to be, if you want to convert a bar scale into a ratio scale, how do ratio scales look? Ratio scales look, e.g., they look like this, okay? It's either 1 is to something, 1 is to 50,000, 1 is to 4 million, okay? These are just examples of ratio scale. So that means that if we want to convert this bar scale into a ratio scale, we want it to be in the form of 1 is to something, and we do not want any units there. Okay, there are no centimeters there, there are no kilometers there, there are no millimeters there. So we want it to be in the form of 1 is to something, and we don't want any units there. Okay, so that's basically what we're trying to achieve. So now we're seeing something here. We've got centimeters, we've got kilometers, all right? So if you want to convert this ratio scale to be in the form of 1 is to something, okay, so if you want to convert this ratio scale to be in the form of 1 is to something, right, all that we need to do is that we just need to divide both sides by a value that will allow us to cancel out the units and allow us to also cancel out the number. Okay, so that basically means here we've got a problem. We've got centimeters here, we've got kilometers there, meaning that we can't cancel out the units. Okay, so for us to be able to cancel out the units, that means that the units need to be the same. Okay, so what does that mean? That means that we need to convert the kilometers to centimeters. Okay, so we need to convert those 15 kilometers to be a value in centimeters, or we need to convert those centimeters to kilometers, so that when we are dividing right through by 3 centimeters, okay, we can cancel out the units and the number on the right hand side. But let's see if I'm making sense. Okay, so what do we need to do? I'm going to choose to convert the kilometers into centimeters. Okay, how do we convert kilometers into centimeters? At this point, you should be visualizing these circles. Okay, so if you're moving from kilometers to centimeters, you multiply by 1,000, you multiply by 100. Okay, so what do we need to do there? It's going to be that 15 kilometers multiplied by 1,000. Let me just make it blue. Multiplied by 1,000. Okay, that puts us at meters, multiplied by 100, that puts us at centimeters. Okay, so therefore it's going to be 3 centimeters is to 15 kilometers multiplied by 1,000 multiplied by 100. It's actually equal to 1 million, okay, 500,000 centimeters. So we've now converted, we've got the same units, centimeters and centimeters on the left and right hand side. Okay, so now it's easy for us to have our ratio in this form. 1 is to something without any units. What do we need to do? All that we need to do now to get our ratio in this form, just need to divide the left hand side by 3 centimeters, divide the right hand side by 3 centimeters, and therefore what do we see? 3 centimeters divided by 3 centimeters gives us 1. Centimeters and centimeters cancel. 3 and 3. 3 divided by 3 is 1. Okay, is 2. Then we are just going to take 1,500,000 divided by 3 is going to give us 500,000. Okay, so we've basically converted now. Okay, the ratio scale of 3 centimeters is to 15 kilometers. I mean, the bar scale 3 centimeters into is to 15 kilometers, right? Into a ratio scale. Okay, that's basically the steps that we need to follow. Or let's say you wanted to work with this simplified bar scale. What do you do then in this case? Okay, same thing here. We've got 1 centimeter is to 15, sorry, it's not 15, is to 5 kilometers. So what does this mean? Again, we want our units to be the same. So for our units to be the same, what needs to happen? We need to convert either centimeters to kilometers or kilometers to centimeters. So I'm going to convert my kilometers to centimeters. So what do I need to do here? I'm just going to multiply by 1,000, multiply by 100. That's just us converting kilometers to centimeters. If you don't know what I'm doing, please just have a look at my conversion video tutorials so that you understand what's happening. So from there, right, okay, 5 kilometers multiplied by 1,000 multiplied by 100, it's still giving us the same thing, 500,000 centimeters. And remember, we need to take it a step further, because our ratio does not have any units. It doesn't have more centimeters there, so we need to get rid of those centimeters. So what do you need to do? Just divide both sides by 1 centimeter. Divide both sides. What you do on the left hand side, you also need to do on the right hand side. 1 centimeter. Therefore our answer, 1 centimeter divided by 1 centimeter is 1 is to 500,000. Okay, so what can we see now? Okay, so we can either do it in this way or we can either do it in that way. Okay, whichever one that you prefer, because I know that some teachers like simplifying it further, but I just keep it the way that it is, like that. Okay, just so that we accommodate all learners. So just keep it like that, then we work with a scale like that. But I feel like sometimes it's easier to simplify, okay, because it helps you better understand that, okay, if I measure 1 centimeter in real life, it's equal to 5 kilometers. So it's always better to simplify, but let's just keep it like that. Even if you just keep it as 3 centimeter is equal to 15 kilometers, that's also still fine. Okay, so now check if she has converted the bar scale to a ratio scale correctly. So there we can just conclude that she didn't. Therefore, she didn't convert the bar scale to a ratio scale correctly. Okay, because remember, she got 1 is to 150,000. We got 1 is to 500,000. Okay, so she made a mistake there. All right, cool stuff. So let's have a look at the next question. So using the bar scale, calculate the distance in kilometers between 2 points on land that are 4.5 centimeters apart on the map. So remember, ladies and gentlemen, fill in what is the info that is given to you. So I'll just write this on the side there so that we can all follow and see what's happening, so that we don't mess up our solution part. Okay, so there for C, we are told that, okay, we are trying to determine what? The distance on the land. So in other words, the distance in real life. That is what we want. Question mark. What are we given? Distance on the map. What is the distance on the map? 4.5 centimeters. They're asking us to use the bar scale, okay, to calculate the distance in real life in kilometers. Easy, okay, because we filled in our information like that, all that we need to do, we're going to take, remember, what was our bar scale? Our bar scale was 3 centimeters is equal to 15 kilometers, or 1 centimeter is equal to 5 kilometers. Whichever one that you want to use, it's the same thing. Potato, we'll still get to the same answer. We don't have to panic, okay? We'll still get to the same answer. So we're going to just basically take that 4.5 centimeters multiplied by, what is it that we want? We want the distance in real life. So just make us like a note for yourself there at the top. So I'm just gonna say 3 centimeters is equal to 15 kilometers. So this is the map, this is the real. Okay, I'm just making some side notes for us there so that we are able to deal with it. So 4.5 centimeters, want the distance in real life. So we're going to multiply by 15 kilometers, divide by 3 centimeters. Okay, what do we get? 4.5 multiplied by 15 divided by 3. We are going to get that is 22.5 6.5 kilometers. Okay, so that's basically now, right, the distance in real life in kilometers. Okay, if you use the bar scale to help you convert that 4.5 centimeters on the map to the distance in real life. Okay, good stuff. Number D, if the distance along a road is 83, so now we're on the road, ladies and gentlemen, we're on the ground, we're in real life, and then they're telling us that the distance on the road, right, is 83 kilometers. What would this measure on the map? So they want the distance on the map in centimeters. Again, right, we are basically going to use what? Our bar scale. Okay, we are basically going to use our bar scale. So what do we do here, right? We are just going to take, so I'm going to do the solution in yellow because now I'm on the black, right? So what do we need to do here? Still, I'm just going to keep this bar scale there because that's basically what we're going to use. This is the solution for D. Okay, remember, fill in the information. We've got the distance in real life, or the distance on the ground, whatever. It's 83 kilometers. We want the distance on the map, which is equal to what? We want to use the bar scale. Okay, 3 centimeters is equal to 15 kilometers, or you can even use 1 centimeter is equal to 5 kilometers. Ladies and gentlemen, you will get the same answer. Ne? You will literally get the same answer. So we don't have to panic and say, but then, okay, then what do we need to do? You're going to just take that 83 kilometers multiplied by, what is it that we want in this case, right? Remember, this is the map. This is the real. Okay, you multiply by what we want. We want the map, so you multiply by 3 centimeters divided by, obviously, the other value, what we have, 15 kilometers. So you'll see there, you take 83 kilometers, multiply by 3, divided by 15, it's going to give you 16.6 centimeters. All right, so that's basically what the distance will be on the map if the real life distance is 83 kilometers. Do you see how easy this is? So easy, like super. It's a breeze, guys. It is a literal breeze. Please just type down, you get my drift if you're following, okay? Because I just want to see if, everyone is really following with what I'm doing here. Please just, type that down there. I also want to see if you're still watching the video tutorial, you're still engaged, if you are in it to win it. Okay, cool stuff. So that's basically what we're supposed to do there. Also, just for fun, let me just show you. You can also say, or maybe you just want to use this simplified one. Okay, so remember the 1 centimeter represents the map, and the 5 kilometers represents the real. So we're going to just take that 83 kilometers, multiply by what we want. We want what? The distance on the map. So you can multiply by 1 centimeters divided by what we have, obviously that other value, 5 kilometers. I'm just checking, I'm just showing you that you literally get the same answer. So 83 multiplied by 1 divided by 5, so same as just saying divided by 5, it's equal to 16.6 centimeters. Okay, kilometers cancel, kilometers cancel. Final answer is in centimeters. Do you see that we get the same thing? So it just depends on you, what you like to do, what you're comfortable with. Okay, that's it. Then you can stick to that method. Okay, right. So if you want to simplify it further to have it in the form of 1:2, you can. If you don't want to, you don't have to, unless the question tells you to. All right, cool stuff. So we are done with these, questions, right? Let's have a look at the next question. It says the map below shows an area in Johannesburg, right? But now we are given the line scale for the map is on the bottom right corner. Okay, so now if you measure this line scale, okay, please remember, right? I'm just going to tell you what it will be. If I measure using my ruler, the distance from this part, okay, from the 0 mark to that mark, okay? So when I measure with my ruler from 0 to that 100 there, and I'm measuring in centimeters, I'm getting that it is 2 centimeters. Okay, so if we measure on with our ruler, just pretend we are measuring with our ruler. I don't want to use the virtual ruler. Okay, so we're measuring with our ruler from that 0 to 100, and I've measured that it's 2 centimeters. Okay, right? Then what does this mean? It basically means that, okay, from us measuring with our ruler, it basically means that then 2 centimeters on the map is equal to 100 meters in real life. Okay, so do you see that a line scale works the exact same way as a bar scale? What you just need to do, you need to measure that line scale. Okay, so therefore we just know that 2 centimeters on the map, because we've measured this 2 on the map using our ruler, is equal to 100 meters in real life. So then we're going to be using this equation, right, to help us answer the questions that follow. Okay, cool stuff. Let's have a look at the questions. Use the line scale to determine the ratio scale for the map. So remember, we found that, okay, 2 centimeters on the map is equal to 100 meters in real life. Okay, so we can actually just write this as a ratio. Okay, we can actually just write this as a ratio, right? How? Just 2 centimeters is to 100 meters. It just means the same thing. 2 centimeters on the map is equal to 100 meters in real life. Okay, so now remember, if they're asking us to convert to a ratio scale, remember, think about those examples that I did with you. Okay, that a ratio scale is, it has to be in the form of 1 is to something. 1 is to, something. Okay, there are no units there, and you have to have that 1 and something. Okay, so now how can we get this ratio in that form? First thing we are seeing, units are not the same. So what do we need to do? We need to make the units the same. How do you make the units the same? You can choose. Do you want to convert centimeters to meters, or do you want to convert meters to centimeters? So you're going to make that decision on your own. Whichever one that you want to do, you're still going to get to the same answer. Okay, so then I'm choosing to convert the meters to centimeters. How do you convert meters to centimeters? Remember, we multiply by. I'm getting this urge of wanting to draw this again. Okay, I'm sensing there's a learner that doesn't know what they need to do. Just right there, I'm that learner. If it's you, multiplied by 1,000, multiplied by 100, multiplied by 10. Right. So if you now obviously want to convert meters to centimeters, according to that drawing, what are we supposed to do? Multiply by 100. Cool stuff. And then let's just do that. So you've got 2 centimeters is to 100 multiplied by 100. Okay, it's going to be 1, 0. Okay, 1, 2, 3 centimeters. So it's actually 10,000. Okay, centimeters. Now our units are the same. Once our units are the same, ladies and gentlemen, we know what we need to do. You just need to divide both sides by that left value. Okay, so that you cancel out the units, you cancel out the number, so that you can also get the left hand side in the form of 1 is to something. Okay, so it's just divided by 2 centimeters divided by 2 centimeters. Therefore 2 divided by 2 is 1 is 2. Then 10,000 divided by 2 is 5,000. Okay, centimeters cancel with centimeters. Nice and easy. We have basically converted that line scale that's basically given to us, right, into a ratio scale. Right, that's it. Question number B. Measure the straight line distance between Rembrandt Park and Eastleigh to the nearest. They like this. Nearest centimeters. Remember, I've mentioned this to you guys, right? If they're saying to the nearest, they're just saying that you need to have your final answer as a whole number, right? So let's just see. So we want to measure the straight line. So now we are measuring using our ruler. So I'm going to measure with my virtual ruler so that you see what we're supposed to do. So we want to measure the distance from Rembrandt Park to Eastleigh. So we want to measure the distance from Rembrandt Park to Eastleigh, right? I'm going to take my ruler. Okay. Ooh, I hope this is clear, but it's like, so if you measure from there to there with your ruler, okay, you can say it's 15. I'm getting 15 centimeters. Remember, my ruler is measuring in centimeters, okay? But okay, I'm just gonna write. It's giving me 15 centimeters. So the whole point that you're supposed to just remember there, right, is that when you're measuring from there to there, right, you measure literally with your ruler. You can choose to measure in centimeters. You can choose to measure in, I think it said in centimeters. So we want to measure in centimeters, okay? And I'm just getting, I actually got 15.1, right? My ruler is like, it's really small. I don't know how to zoom this in, right? But I'm getting 15.1 centimeters. And if you had to now round it off to the nearest centimeter, it will just be 15. Okay, so remember, I'm just using my virtual ruler. Please, guys, just get that. Okay, so if you've looked at this activity in class and you got a different value because you had the physical paper, it's okay, because now remember, based on this, the scaling, it's going to be different. And it's imagine we're learning about scales. Okay, so please take note of that. So I'm gonna write down what I'm seeing from my ruler, and I'm getting that I got 15.1. I'm gonna write it like that. It's 15.1 centimeters, but remember they ask us to round it off to the nearest centimeter, né? So that is approximately equal to 15 centimeters. Because if you round it off to the nearest centimeter, that means that you're going to look at this one. That one is going to tell us what we need to do to the 5. So it's just telling us that the 5, right, just needs to stay the same. Okay, we don't have to change it. So it's just 15 centimeters. Okay, now, so this is the value that we get, né, when we now measure with, you know, my virtual ruler. Okay, this is just the virtual ruler. Okay, so that you get what you need to do. But now, right, if you actually now, you know, if you have the physical paper, okay, if you have the physical paper and you're actually measuring this, let's say for example you have this, you know, class activity, because I got it from e-classroom. So maybe you printed it out and you've got it, right? And you really just want to check what's happening there, right? So I'm just going to work with now those values that were given there, okay? If you're actually measuring from there to there, let's say you've got this printed out, okay? You've got the physical paper with you, okay? You're supposed to get 6 centimeters, okay? The distance from there to there, when you're measuring with your ruler, you're supposed to get 6 centimeters. So I'm going to use that now, okay? So this is now if you've got the physical paper, okay, right? So if this is, please, I hope you guys are getting me, okay? So if you've got the physical paper with you and you're measuring, you should get 6 centimeters, right? So if you take that 6 centimeters, right, this is now what we're going to work with to help us answer question number C. Okay, so now they're asking us, right? So I'm working with the physical paper now, right? This, I'm going to work with these values, okay, so that we just accurate now, right? And then that everyone is following, okay? So if you've got the paper with you, you measured 6 centimeters. So we want to work with that 6 centimeters now, okay? This part was just for the purpose of explaining so that you guys can get what you need to do. When they talk about measuring, you just literally need to measure with your ruler. Okay, so calculate the real life distance between these 2 points in kilometers. So remember, we already know that this map uses a line scale, okay, that has the equation, right? We determine from the line scale that 2 centimeters on the map, right, is equal to 100 meters. Or you can even use now, because now we've already also just converted, you know, this line scale into a ratio scale, you can also just use that 1:5,000. Whichever one that you want to use, it's still fine, provided that you've converted it correctly. Okay, so let's just start with the initial one that was given to us. What would be the real life distance? I'm just going to write here the values. So remember, we were given that this 6 centimeters is the distance on the map. Okay, so the 6 centimeters is equal to the distance on the map. What are we trying to do? They want the real life distance. Okay, what are we supposed to do? Remember, 2 centimeters is equal to 100 meters. The 2 represents the map, 100 represents the real. Okay, so what are we supposed to do? Okay, So what are we supposed to do? You're just going to take that 6 centimeters multiplied by what you want. Okay, because remember, we want to work with this answer. Okay, so we're going to take that 6 centimeters multiplied by what we want. What do we want? We want the real. So you're going to multiply by 100 meters divided by what you have, which is the map. Okay, or the other value, which is 2 centimeters. Okay, so what do you see there? Okay, 6 multiplied by 100 divided by 2, or 6 multiplied, okay, is actually going to give us 300 centimeters, and the centimeters cancel, and you'll have your answer in meters. Okay, so we've got our final answer in meters, but remember, they asked us to give our answer in kilometers. So what does that mean? We basically need to convert these 300 meters into kilometers. How do you convert meters into kilometers? Just look at this diagram here. You're just going to divide by 1,000. Okay, so you're going to just take the 300 divide by 1,000. So what do you get? You get 0.3 kilometers. Okay, or okay, maybe let's say, for example, you just wanted to use this line scale that we've created, né? That 1 is to 5,000. So what does that mean? Remember, 1 on the map is equal to 5,000 in real life. Okay, so same thing here. You're just going to take the 6 centimeters, multiply by what you want. We want the real. So you're going to multiply by 5,000. Okay, divided by what you have, obviously the other value, which is 1. So if you take 6 multiplied by 5,000, what are you getting? You're getting 30,000 centimeters. Okay, but remember, they want our answers to be in kilometers, so you're going to take that 30,000 centimeters. How do you move from centimeters to kilometers? You're going to divide by 100. Okay, and divide by 1,000. So you're going to divide by 100, divide by 1,000. It's the same as just dividing by 100,000. So your final answer is just 0.3 kilometers. Okay, so whether you want to do it like this or like that, it's the same thing. Okay, it's the same thing. Okay, let's look at question number D. It says, calculate the length of the portion of the N3 shown on the map in meters. Okay, so also the same thing that you have to do here, right? Because they want the length of the portion. So what's the portion of the N3 that is being shown on this map? It's on this map. It's that one. Okay, so all that we need to do also with this question, right? Because they want you to calculate the length of this portion of the N3 that is shown to us, is that you basically need to now, with your map, right? Just get. So obviously maybe you'd measure the distance from there to there, right? That straight line distance, then plus the length from there to there, that straight line distance, plus from there to there, plus with your ruler. Okay, so you can just use a ruler to just get those small, like for me, what I would do, I would just get the straight parts. So get that one, measure that, then measure this from there to there, then measure this from there to there, right? And then measure that from there to there, then just add them together, right? So this is just a matter of us just measuring, ladies and gentlemen. We just need to measure. So when you measure from there to there, what is it? Plus from there to there, because you're just working with the straight lines, okay? Because you won't be able to curve with it like that. Okay, so just measure from there to there, plus from there to there, plus from there to there, plus from there to there, right? And get what the measurement is from your map. Okay, so for example, if I had to now use my virtual map, my virtual ruler, right? So what I would do, okay, I would measure the distance from there to there. Okay, start from there, and then I would say that, okay, I'm getting like 5, right? Plus, then you measure the distance from there to there. Okay, then you'll get like 12 plus. Do you get my point? Okay, so that's what you're supposed to do to basically help you get the length of this portion of the N3. Okay, so if you now obviously have this physical paper, right, with you, you can actually download this worksheet. It's e-classroom, right? Okay, you'll see that, okay, the length of this portion, if you actually printed out this worksheet, it's supposed to give you 8.5 centimeters. Okay, it's supposed to give you 8.5 centimeters. So I just showed you how you can go about measuring that with your ruler. Okay, but remember, because I've got a virtual ruler, guys, we all know what's the situation, right? Then if you get 8.5 centimeters, right, we want to determine the length of this portion, right? Okay, so they want you to determine what is the length of this portion, right, of the map, or the portion of the N3 that is shown on the map, right, in real life. So you can still use that scale 1:5,000 to help us convert then what's that measured length on paper, right, to the distance in real life. So from there you can just take that 8.5 multiplied by what you want. So you can still just use this scale, multiply by what you want. We want the real divided by 1. So if you take 8.5 multiplied by 5,000 divided by 1, this is equal to 42,500 centimeters. And then remember, they wanted in meters, so you just need to divide this answer by 100. So if you divide by 100, okay, you'll find that the length of this portion is actually equal to 425 meters. Okay, so just remember here, it can seem a bit confusing. Calculate the length of the portion of the N3 that is shown on the map. Okay, so here, yes, we are shown on the map this length of the N3. Okay, we are shown what this is. So the first thing that we have to do here is just determine what is the length on the map. Okay, but now they actually just want you to determine what's the length of the N3 in real life. So yeah, it wasn't really clear, but they just want you to determine what is the length of the N3, right, in real life, right, in meters. So that's why we basically did this. Let's have a look at question number E. Now, this is just a question where we need to just think about this for a second. Now, if a map is resized, could you still use the line scale and the ratio scale? Okay, if you were to resize the map, which scale would you still be able to use? Would it be the line scale or would it be the ratio scale? So now remember, if you're resizing a map, let's say for example, you've got a big map or a small map, and then you want to print it on bigger paper, right? Okay, there's a scale that's given to us there. Which scale would we still use? Let's say, for example, you're given a line scale. Would you still use that line scale if you were to, resize the size of that paper? Yes, you would still use that line scale, because if you enlarge a paper, right, even with that line scale, because the line scale, right, you can measure, okay, the distance on the map to give you the distance in real life. When you resize it, it also resizes the scale correctly. But now, when you basically resize now a map that has a ratio scale, it doesn't resize according to that ratio scale. So that means that you'd have to now recalculate the new, ratio scale there. Okay, so if a map is resized, you can definitely still use a bar scale. You can definitely still use a line scale, but you can't use a ratio scale if you resize it. So now that's the disadvantage when it comes to a ratio scale, that if you have to resize, then you have to work out now the new scale. But if you're using a line scale and if you're using a bar scale, if you have to resize, then you don't have to, worry about now changing the scale as well. You can still use that line scale, bar scale, the way that it is. Okay, so I'm not going to write that down. I hope you guys, got what I was saying there. Okay, so I'm going to stop it here for today's video tutorial. I think it's a bit too long, right? And then we'll probably do this some other time where we're just doing, it's a fun activity, or you can just do this for yourself. It's a fun activity. Look at this. They're asking you to just complete the following table, right? If you're given this ratio scale, what's the map measurement? What's the actual distance? Simple. Okay, multiply by what you want, divide by what you have. That's all you need to do. So check to see if you are able to answer A, B, C, D, and E, right? Just check to see if you are able to answer that. Maybe I'll just upload like a 5-minute video tutorial where you can just check and see if you are able to, do that correctly. Okay, so that is it for today's video tutorial. Ladies and gentlemen, I hope you enjoyed it, and I'll see you guys on my next upload. On the next upload, guys, we are starting now with analyzing maps. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.